This is the $49 FPGA board with 500 megabytes of I/O bandwidth. It consists basically of the Avnet Spartan 3A evaluation board, which is $49, plus a dual Ethernet Gb PHY daughter card, which I made. Here's a closer view of the Avnet Spartan 3A FPGA evaluation board. You can see the Xilinx FPGA. It's 400,000 gates rated. There's also the Cypress PSOC device, which can be used as a to D, as well as it's also the USB interface. And there's an optional jack, 5-volt jack for additional power. There's 4 pressure sensitive switches which can be used as input to the FPGA. There's some additional headers for JTAG programming, and then of course there's the 40-pin I/O headers, 100 mil spacing, and there's also a flash memory chip on the other side of the board. Here's a closer view of the dual Ethernet Gb PHY daughter card. It's a very basic card, has 2 RJ45 jacks, 2 Ethernet Gb PHYs, and 2 voltage translators, and it's simply wired up to the 40-pin header, expansion header of the FPGA board. The 2 Ethernet Gb PHYs offers 2 receive channels, each one running at 125 megahertz, 125 megabytes per second, and 2 transmit channels also running at 125 megahertz. So there's 4 channels at 125 megahertz, full duplex, and that gives you the 500 megabytes of I/O bandwidth. Each channel is actually 4 bits, so this is running at double data rate. So each channel is actually running at 250 megabits of speed, which is surprising to me that this plain old 40-pin header could actually handle it. But you know, on second thought, this is not too surprising, because if you look at it, there's only about 2 to 3 inches of distance between the FPGA and the voltage translators. There's no terminating resistors of any sort, but with such short distances, it actually all works out. Here's the FPGA board in operation, and I'll be showing you what the signal integrity of the signals at the 500 megabytes I/O look like. Here's what the signals look like on the 40-pin header. The top trace is one of the 125 megahertz transmit clocks, and the bottom trace is one of the related data lines. The scale is at 10 nanoseconds horizontal and 2 volts peak to peak. So you can see that the signals are actually reasonably clean. It's not perfect, but it's 125 megahertz, and the bottom trace is 250 megabits data rate, and for a $49 board and some wires, it's pretty clean, and it works. Okay, this shows the Avnet Spartan 3 FPGA board with the dual gigabit Ethernet actually running. This is doing a ping. The PC is sending packets to both Ethernet ports, and the logic in the FPGA is returning the packets. And I'll stop it to show what it looks like. So we can see that this interface is using Linux raw packets. Raw packets is terrific because it gives you total control over the packet, and you get all of the data. And we can see that the FPGA returns the packets that it receives, and the two packets are of different types. The ping packet will fail, of course, if the CRC is bad. So the fact that it can continuously run is a fairly good indication that things are working well. And so there you have it, a $49 FPGA board with 500 megabytes of I/O bandwidth.